is clear on the ground here, Rachel. And what I want you guys to focus on is, okay, I'm going to send a positive pulse towards Rachel. Alex, maybe stand down there by her so you can get the whole thing.
Yeah.
Just don't get me in.
Get Rachel in it.
You just hold it in one place, okay?
Okay.
Everybody see that?
Ew.
Right, I'm sending a positive pulse towards her, so I'll do it again. Okay. All right, now for practice, Rachel, I want you to do the same thing. Start with it that way and then
So
send it
push it
positive.
that way?
Yeah, so this will be the positive side.
Okay.
Just bring your hand down a little quicker so it's a more pronounced pulse. That's good. Perfect. Okay. So now, what happens if, while my pulse is going towards her, she sends a pulse towards me?
It's gonna explode in the middle.
What happens to the two pulses? What happened?
It's gonna explode.
It's going to explode in the middle. The spring's going to break apart. Okay. So we're going to do that. Who wants to be our counter? So we'll go 1, 2, 3, go, and we'll go on go.
Well, isn't it just gonna move the whole way over there? Like, isn't the whole slinky just gonna move that way?
We're going to see.
Okay.
So you're going to do exactly what you did, and I'm going to do it on 3, and then our pulses will meet.
Okay.
So, I don't know. Shrap, you want to count? So 1, 2, 3, go, and we'll do it on go.
Okay.
1, 2, 3, go.
Okay. So did you see it? What happened
They're
when
like
they met
pushing
in
each
the
other
middle?
away.
Do it again.
1, 2, 3, go.
What are we seeing? Let's talk first about what happens when they're at the same place at the same time.
I can't tell if they're pushing each other away or if they're like going through each other.
You can't tell if maybe they're bouncing off each other or maybe they're going through.
I feel like they're going through.
But that's what happens after they interact, right? What happens right when they're both intersecting? Go ahead, Ryan.
1, 2, 3, go.
What do you see about the displacement of the spring? All right, so watch the displacement. Now you know what to look for. Go ahead.
1, 2, 3, go. So bad.
Oh, the wave goes on the other side. Was it?
That's not what I'm looking for yet. What about the displacement? The amplitude.
Got bigger.
Go ahead, Ryan.
1, 2, 3, go. I got more stretch in the middle.
What's that?
I got more stretch in the middle.
It got more straight, so the amplitude was actually greater, right? When they overlap, the amplitude when it's overlapping is greater than either individual amplitude. Now watch for that. Go ahead.
1, 2, 3, go.
See how it, right, it goes out more. Okay. Now, do they bounce off each other or do they keep going?
Go through each other.
So in order to determine that, Rachel, you'll send the pulse that you've been sending. I'm gonna send a smaller one.
Okay.
And what I want you to focus on is, does the smaller one keep going or does it come back towards me? Go ahead, Ryan.
1, 2, 3, go. Keeps going.
Keeps going, right?
Ew.
One more time. Go ahead, Ryan.
2, 3, go.
And the big one comes towards me.
Yeah.
It's supposed to be on YouTube.
Okay?
So, on YouTube.
So therefore we know
I
that,
ruined our video.
right, they pass through.
It's on YouTube.
Now, this time, Rachel's going to send the pulse she's been sending, and instead of me going this way first, I'm going to go this way first. So in essence, she's sending a positive pulse. I'm going to send a negative pulse like this. And I want to see what happens when they meet in the middle. Okay?
1, 2, 3, go.
What do you see happen? Anything?
They just keep
Go
going.
ahead, Ryan.
1, 2, 3, go.
They switch places.
How about right in the middle when they meet? Go ahead, Ryan.
1, 2, 3, go.
And it's hard to see because it happens so quick. But what you should be seeing is that both amplitudes actually cancel, and for an instant, there's no amplitude. Go ahead, Rachel, or Ryan.
1, 2, 3, go.
And just for that instant,
Oh, I see.
they're canceled. And we'll see a slow motion video in there to see that. So both of these things, we'll look at some slides now about what this is and some other examples. Let's go back in, we'll come back up. So basically what we have, there's a wire, okay, and then there's these spokes attached to it. So I can put waves along this thing. Right, it can make waves travel. Now what we want to do is have interference. So Josh, would you mind doing waves on that end?
Sure.
And then they'll meet each other. So I'll let you just feel it out first. So just raise it and lower it, nice and controlled. Go ahead. Right, and yeah, actually step to the side a little bit so these guys can see. I'll push it that way a little bit. Can you guys see it now over there? Hannah, can you see it? Okay. All right, so what we'll do is we'll count to 3 again. I'll make a wave.
You want me to count?
Sure, and then Josh will make a wave at the same time. Make another one, Josh.
Sure,
so you see. Okay. And then watch what happens when they meet in the middle.
1, 2, 3, go.
On go, we'll go. Go ahead, Ryan.
1, 2, 3, go.
So you see the constructive, right? And it gets raised so much in the middle it actually hits the wood. You could actually hear it too. Go ahead.
1, 2, 3, go.
One last time. Ryan.
1, 2, 3, go.
Okay, so it builds up, right? Now what we'll do is I'll send a negative pulse towards Josh. Josh will send a positive pulse towards me. And you watch for the destructive interference.
1, 2, 3, go.
We'll do it again.
1, 2, 3, go.
Can you see it? The destructive happening? The video I'll show you will be slow motion. One more time.
1, 2, 3, go.
Oops, I dropped it. Sorry. Go ahead, Ryan.
1, 2, 3, go.
There we go. Okay.
Here is a torsion wave of medium amplitude traveling left to right. Here is a wave of the same amplitude traveling right to left. We'll now send these waves in simultaneously to show what happens when they meet. The amplitudes add as the waves pass through each other. Then the waves continue on their way unchanged. What will happen if the waves have equal but opposite amplitudes? The waves cancel momentarily, then pass on.
You're not going to do anything. Just hold it. Don't let it move.
Okay.
And I'm going to send a pulse towards her. And basically what I want you to observe is what's happening after it gets to her. Right? So it comes to her. What happens?
It goes on the other side.
Right? So it flips direction, right? The actual amplitude switches sides and then the energy comes back to me. Okay?
I feel like
So when
it's the other
what
side.
we'll see in there on the slide is that when a wave reaches the end of its medium, and there's a boundary over there, Rachel's the boundary, the wave reflects. Okay, and the nature of the boundary determines whether or not you get an inverted wave coming back or one in the same direction. So when the boundary is fixed, you get an inverted wave. Now what we'll try to do is simulate a free end, so that, now what I want you to picture is gravity, like imagine that gravity's pulling that way. And I can't, if we hold this up it'll sag, so we can't do it. But if you picture gravity pulling that way, and a wave comes towards me, if I'm, like imagine that I'm not holding this, so that this is actually free to move. So if Rachel sent the pulse this way, and her pulse was that way, what would this end do if there were nothing holding it? Right, it would fly this way. But if gravity's pulling that way, then it would come back down, right? Once the energy came and left. So I'm going to pretend like my hand is free to move and imagine that this is a free end and gravity's pulling that way. So Rachel, you'll send a pulse this way. Right? And then if the end's free to move, imagining that my hand wasn't here and gravity was bringing it back, do it again. How does the wave go back? Right, it goes back the same, right? So if this was a free end, where this end is free to move when the wave comes to the end of its boundary, then it comes back the same, it's not inverted. One more time. Right, that's what would happen. It's really hard to demonstrate, so that's why I gotta do it that way. Okay, so we have fixed end reflection and free end reflection. You don't need to count. Does it look like it's coming back inverted, Trev?
A little bit.
Somewhat, right? One last try. You were able to see it? There we go.
Yeah.
Okay, and now we'll do free end. You can just leave it. One more time. There we go. I saw it there.
Yeah.
All right, so today we did reflection and interference. Tomorrow we're going to look at the combination.
We'll send a torsional wave down this wave machine to show what happens when the wave reaches the end. When the rod at the end is free to move, the wave reflects back with the same positive amplitude as the incoming wave. If we fasten the last rod on the machine so it can't move, the reflected wave has an amplitude opposite that of the incoming wave.
When a wave pulse on a spring reaches the end of the spring, some or all of the wave is reflected. In this first case, the end of the spring is attached to a rod so that it can't move. Here's how a wave reflects from the end. We'll repeat that in slow motion. Notice that the reflected wave is an inverted version of the incoming wave. Now we'll tie the end of the spring to a long, light string so that the end moves freely. The wave now reflects without inverting. Let's compare the two types of reflection side by side.